Hello, I'm Bas Hamer from Possum Labs, and today I'm here with the fourth of the advanced tutorials, which is dealing with Slipka. So Slipka is a unique little monster. It is a proxy built to tamper with traffic. Actually, we'll first take a look over here. So what it does is it allows you to intercept and record and modify requests that go through the proxy. The way it works is you effectively build a proxy which is single use, and then when you are done with the proxy, you just let it close, throw it away, and you're done with it. And that way, each test can effectively spin up its own proxy and modify the behavior as needed. So we're going to take a quick look here at two of our scenarios. This is an explicit version of using Slipka, and this is an implicit version of using Slipka. So what we do here is we say that we're going to be using a proxy. We're going to configure the proxy to look for reports. And then we're going to start doing simple stuff, right? We're going to navigate to the website. We're going to go to login, enter a username and password, show that part still works fine. And then we're going to navigate to this PDF file so that we can actually show that we can intercept with this file and get it back. And then we're actually going to retrieve the file. So we do have a wait in here. The reason this wait is in here is because there is a little bit of delay before the files will show up in Slipka. There's a lot of multi-threading stuff happening at the same time. And when you send a request to Selenium, some of the requests will be asynchronous, right? So it's not going to wait for those requests to actually finish before doing something else. So that's why there's a delay in here to make sure everything does finish what it's supposed to do. So how the hell do we make this work? Well, so what we have to do is nothing in the framework initialization. I believe this is just the out-of-the-box version, but we do have a new file here called Slipka Steps. So what we are doing in here, first of all, we have a proxy file, which is our little entity. It has a memory stream that we keep around, so we can reread the file if we need to. And we have this repository we create for these proxy files. So there's a couple of things you have to configure. First of all, we're going to set up a proxy with both a location where the proxy is located. By default, it is going to be located at port 4445. Mine is set up for localhost. We'll take a look at the Docker Compose file after this to see how that's set up. And then what it's in front of. What's in front of in this particular case is possumlabs.com. So this tells you where the proxy is located. This tells you where the proxy ought to go. And now we create this lazy, which means it's only being evaluated when it's needed. Implementation for a proxy wrapper, and it will spin things up. So when we actually do need the proxy, right? So we either have an attribute called proxy, or we say using a proxy. What we do is we get the value of our proxy, we'll ask for the URI, and then we'll find the port. So the way that it works is it will just spin up the proxy on a new port for us, and each proxy will have its own port. And then when you're done with the proxy, you can just discard it. This is where we check values. This is where we can log calls to specific locations. Here's where we can retrieve the file. So the way that you retrieve files is you just say proxy.value.getCalls to list. And then you can look in here and see like, oh, what do I care about? What do I not care about? And then over here, what we do is we go to our potential records and we say like, okay, we should have a record that is recorded. Right? If we don't have any recorded, we'll throw an exception. If there's too many, we'll throw an exception. Doesn't understand it right now. So, and then we just create memory stream and we download the response for that particular call. So that is how we get back the memory stream. Then the most important part is, of course, how do we configure the proxy? Well, the way that we configure the proxy is down here. What we're doing here is we effectively say, okay, we are looking for anything with content type of application PDF or Excel or OpenXML. This is usually the things that you tend to want to intercept. But because our test server is kind of dumb, we're just using GitHub pages right now. There's no actual server behind it. We just look for anything that has the pattern of .star. It's a regular expression, .pdf. This dot, of course, will match anything, but it's easier for people to read it this way. So we've told it to record anything that has either of these three content types or anything that had a URL that has .pdf in it. So yeah, that's all you have to do, and then you just route through it. So the interesting thing that we then end up doing for the routing through is over here, we effectively update the base URL. We update it to Slipka in this particular case, and this again comes back to how our Docker Compose is set up, and then we just provide that port number. I believe it does strip out any HTTPS. In general, you shouldn't be using this with HTTPS. I don't see much of a reason to do that in your test environment anyway, although I'm sure people have their reasons. So let's take a look at Docker Compose. So what we have in here is a basic setup, right? You have our Chrome node, we have our hub, and what we've done is we have this additional dependency on Slipka. So when you look at this, and they have dependency over here as well. So this means that whenever we enter Slipka, it will resolve to our node called Slipka. Our node called Slipka is based upon /Slipka, depends on the database, link to the database. This is the port at which we are exposing it, and this is the range of ports that we are making available for a proxy. All right, so you see that there's a fairly wide range, 201 ports, I believe, we're opening up. 210 ports. Now, not all of these ports are going to be available. It will actually check what is available, and it will just skip over ports that are already in use for whatever reason. Slipka itself works fairly well with low load. Once you have a lot of load on Slipka, it's not going to work well. If you have patch operations, so this is in reference to like put, post, delete, patch. If you do patch, it's not going to work because Slipka is written on .NET and doesn't support that. And it uses some technology that I thought was standard, but apparently isn't. So yeah, don't use this if you don't need to. But if you do need the ability to intercept some traffic or do some things like the, annotate additional headers for all requests that are associated with the test, Slipka can provide you with a solution for doing that. That's about it. It's relatively simple. It doesn't really do a lot, but what it does fairly well. Just keep in mind that this is really more of a testing tool. It's not really something that you want to put in production. Don't think that this can be, a new proxy to solve any of your problems. Is really meant for a specific purpose where you configure a proxy, it's short-lived, and it tampers with traffic, right? Which is usually not what you want your proxies to do. And usually not how you use proxies, but for testing it works rather well. Okay, that is pretty much everything that I need to cover when it comes to Slipka. Again, it's an extension point. Don't use it unless you have to. But you should be able to walk through the example and see exactly what's going on and how things work. Also, if you want more examples on how things work, what you can do is you can go to possumlabs.dsl. And then I believe there's the Slipka integration test project, which has a number of examples on how you can use things, right? So what we did before was the recording. This is an example of how we do recording. Most of these scenarios are all set up to use multiple proxies in front of each other. So we have our first proxy, we have a second proxy in front of the first proxy. We configure proxy 1 to respond with hello world. We configure proxy 2 to record a call. When we then make a call to proxy 2, we should be getting the hello world, which came from proxy 1, but we should also be able to retrieve the response from proxy 2 and verify we get this hello world as well. Right, so this is the idea of recording pattern. You also have patterns of decoration, right? So now we have proxy 1, proxy 2 in front of proxy 1, proxy 3 in front of proxy 2. What we're doing is proxy 1 is just the dummy response from hello world. Proxy 2 records any get calls. Then we have proxy 3, which is adding an additional header with a value of test. Right, so now if we make a call to proxy 3 and we ask proxy 2 for a response, we should see that additional header show up. So this is some examples of additional behaviors you can use with Slipka, and you can look in here as to how things work. But the tutorial is primarily focused on how you can actually just get it up and running, get your first calls going through it, and then you can get through and get to those juicy report files. Now, does this help you actually interpret and pull data out of a PDF? No. If you want a solution for that, me too. I've not seen anything good. I think Amazon's service is best, but only if you take your PDFs and turn them into images and then upload them. But, you know, it's been very hard to reliably get tables out of PDF files. I've not seen a good solution, especially not when you're dealing with Crystal reports or some of the older PDF generation tools out there. So yeah, this just gets you to the file. It doesn't solve any of your other problems you're going to have after that of actually reading those files. Again, thank you very much for your time. This wraps up the tutorial series as it's planned at this time. I'm sure that there may be more of them in the playlist up ahead, but if nothing else, thank you very much for sticking with us up until this point. There will be some additional information about contributing to this project and just walkthroughs of the source code and what lives where and what the thing's called. But, you know, if you're not planning to contribute to the repository, I would avoid all that. Thanks again, and please leave feedback below.